It's a boring topic, so I'm glad that nobody came for it. The one thing that I do, I like to make fun of myself. So let's have a good time and go for it. Are we good on video or whatever? I don't know. Whatever. All right, cool. My buddy Adrian, he helps me out. So my name is Evan Davison. This is kind of an update on a talk that I gave last year called Dungeons & Dragons, Siege Warfare, and Fantasy Defense in Depth. And it really took a turn in the middle of it that had absolutely nothing to do with Dungeons & Dragons. And we were talking about escalation of warfare. And so I'm going to do a real quick recap of that here at the beginning. But these are a few of my favorite things. I work at a big name vendor that you can find out. I like to break stuff. So if you get a chance, check out my blog. From time to time, I have time to post of the fun stuff that I break, like the magic on the right. One of the talks that I've got coming up in October is Hacker Halted in Atlanta, talking about how to take over the United States Emergency Alert System. So if you're interested in that, it's rather interesting. Some other stuff that's coming up, DerbyCon, SkyDogCon, some of those other ones. So what I figured we'd do is we'd start, especially for those of you that that weren't here last year, to check out, to kind of recap some of the stuff and go back in time. And if the theme of Austin Powers is not, interesting to you, I guess I can try to get a little bit more animated or something. Groovy baby, yeah, I don't know. But last year we sacrificed this dude called Admin Dude, and we kind of talked about how, as security professionals, we can deploy tons and tons of stuff and try to implement defense in depth and all these types of things, but ultimately, the failure is to recognize that information warfare is an escalating type of thing. And so if we take into account all these different things that we do, like we study the past of information warfare or the history of warfare, we see that defenses are meant to be overran, that there's this escalation of arms that happens and things like that, and the progression of warfare from physical defensive tactics and things like that into information warfare and all that other type of stuff. And so what we learned last year is that we're fighting this lesson of futility, that we can't keep the bad guy out of our networks. We can't keep in general, the internet isn't a safe place. Anybody disagree? No. Yeah, throw something back at me, all right? Like physically, verbally, whatever. Keep yourselves awake, entertain yourself however you can. So ultimately what the talk was about was this progression of things. And so some key concepts I want to kind of key in on before we get into the absolute mind-numbingness of an encryption framework that we're going to talk about here. Let's kind of get this concept. So in the beginning, when we first started to get into, the interwebs of sorts, we wanted connectivity. That was what everybody clamored for, right? You wanted access to the internet, you wanted access to the information, that type of stuff. And then as time has gone on, it's become a little bit less about connectivity. We expect connectivity wherever we go. We go to a hotel, we expect there to be internet. We go to a coffee shop, we expect there to be internet. Then it became about connectedness, which is this concept of that I want my data wherever I am. So I want to be on my smartphone and have the same PDF file that I have on this other device as I have on this other one, and that everything syncs, and you get into this concept of pervasive ubiquity, which is kind of this next step, this next evolution of where the internet is going, which devices are aware of each other and devices connect to each other, just like your laptop connects and they share bandwidth and they do all these crazy things. And some of this stuff is largely theoretical, but the idea comes into that, that devices don't have to, that we're going to move away from this aspect of having connectivity, that devices will become much more connected. And we have this concept of, like I said, connectedness, where things will continue to help each other out, if that makes sense, that your data will be all over the place and that it will exist in the cloud or wherever it is. And so, again, why is this important? So as we continue to move forward and as we start to see stuff, we have this concept, some of these concepts, I'm going to move this mic around because I keep turning my head. We have this concept of some of these things that are coming into play, like software-defined networking, where and application networking, where things aren't interacting anymore in this concept of physical data interchange. This is stuff that's happening at layers of the OSI stack that that regardless of where they are, that devices become directly connected to each other or directly aware. So even between, like when you think about Amazon, AWS, and all these other types of services, you allow data to interact in a memory layer, right? So that things are much more, we don't have to go up and down physical connections between servers. That we can, how can we virtualize this concept? So you start to get what I call like a memory hub of sorts, like where you have memory shared across. Anybody follow me on that? Big concept, I don't know. I'm not an expert on it. I call this my buzzword slide, I guess. The Internet of Things, zero infrastructure, borderless networks, IPv6, all these different things. Like the concept that they're introducing is that everything is always connected. We're seeing this disintegration. Last year we talked about the erosion of the perimeter. So this concept of a border that you can protect, this concept of a defense in depth mechanism that you can employ to keep the bad guy out, that there's some delimiter or some line that you can lay out in the sand that says this is mine and that is yours, is completely obscured, and if it doesn't absolutely fail to exist anymore. And so this gets even further into things like when we talk about our data. So we talk about where we're storing our data, like iCloud, the new, OS X, I haven't played with it yet, but it's iCloud is directly integrated into it, so your data is synchronized, and you can fire up your iPad and have the same documents in all these different places. Your services like Dropbox and so forth. This line of what is the file system now is completely obscured. We're not even talking about like what is an asset and what is a physical connection between two devices. You're talking about file systems now become virtually connected wherever they are, and now you have this aspect of virtual connectedness that didn't exist before, that our current defense mechanisms don't really deal with very well. So let's take a moment to reflect on all of that. And Mr. Bigglesworth, nobody. It's okay to laugh, people. If you don't laugh, I'm going to cry. So, Adrian will come console me later. So last year, some of these slides were from last year. So if you saw this presentation last year, all like 1.5 of you, yeah, because the other one, never mind. Half of me, because now I'm mentally brain dead. Security in the current context of things equals hardening devices and deploying products, right? We implement solutions, we draw our boundaries around things, we have our firewalls, we have our IDSs, we have these things. There are more modern approaches, and you're going to hear some great things if you're here for Black Hat and DEF CON and all that stuff. There's all sorts of great stuff that happens in those areas, but ultimately those are stopgaps, just like the concept of building a castle ultimately became inferior because they realized that the resources and the assets that made the castle possible were outside of it. And then if you hold up inside of it, you don't really get the benefit anymore. Ultimately, economically, things start to fail. So that was kind of a concept of last year. And we were talking about this, like I said, you're not able to draw a perimeter because the benefits of having that perimeter ultimately undermine the benefits of keeping things open. And so this is kind of a current type of aspect of it. We keep the bad guys out, therefore our data is confidential, and we clean up after something happens, so we can kick the bad guys out. But one of the concepts that was introduced last year was, and this is something that's starting to gain traction in a lot of academic circles, or even from us as security professionals, we talk about that we're having to deal with states of continuous compromise, right? That even if we kick one bad guy out, just another bad guy gets in, or maybe we never get rid of them. Maybe it's just, we don't even know that they're there, or whatever that may mean to you. So something that's a little bit more realistic is that security really is about minimizing data exposure. Can I keep things into a perimeter? Well, maybe, maybe not, but that may be one methodology, that avoidance type of risk management practice, that if I can encrypt my data, protect my devices, and prepare for an inevitable breach, it's a little bit more proactive. And the reality is that it's not any one thing, but a combination of multiple things. And so what I need is something that allows me to keep that data exposure to a minimum, that allows me to effectively encrypt and protect my devices, and gives me some mechanism to defend my data or defend things when the inevitable breach does happen. And so the way that this kind of started out was, just like, how do we do this, right? Like, okay, we're talking about a bunch of different concepts kind of strung together. Evan's not making any sense in the world. And that's kind of how it started last year. We were looking at this, and as we were studying the defensive networks and kind of trying to bring you guys something of meaning to talk about was, what does this look like? I mean, how do we really do this? How do we defend ourselves? How do we create something? Why is what we have now not working, or what does work versus what doesn't? And maybe are we doing this the right way, or are we just doing this completely incorrectly? And the answer is, I have no idea. The answer is different for every single organization, and it depends on what you're trying to defend. But we kind of looked at it at an aspect of, like, what do we have out there already? And so one of the things that we introduced last year was this concept of, I won't say introduce this concept, that is completely false, but borrowed this concept of, for this, what we're calling kind of presentation layer 6.5, and I'll get into more of why it is that in a minute, is that security is 3D. And so we showed this. This is a slide that I stole directly from last year, so I had to make one less slide. Saved me all of 5 minutes. But awesome, because it was 5 minutes I needed. Is that, and I'm going to let this kind of warp your mind for a minute, but that all of these things are competing with each other for security. So you have transmission, storage, and processing, how data is interacted with. You have the basic CIA triad of information security, confidentiality, integrity, and availability, and then other places where information security is implemented. So you have technology and policy and process and the human element of things. And so last year we kind of looked at this and said, what do we really have now? If we look at the existing mechanisms that are out there of how my data interacts, or how I interact with my data, what's realistic? And so we've kind of got transmission covered. We've got SSL and VPNs and all these cool technologies that are out there, and we've kind of got it from a technology perspective, and that gives us some confidentiality. It gives us some level of integrity. So I'm not going to go through all the examples, but you can kind of see how all these things compete with each other. And so ultimately, like, some of those squares could be green, in one direction, but any of the other directions can completely negate them. So what is realistic? We look at this and it's like, how can you get this to all green? Because obviously humans have not yet learned how to read encrypted data. And then if we did at that point, if it was human readable in some way, it probably wouldn't be encrypted anymore. So that, and the inevitable piece of this is that the weakest point in any type of security element is the human element. And we're not going to get around that. So how do we get as close to this as possible? Is this even realistic? Let's explore it a little bit more and find out. So let's explore encryption and technology from the perspective of the stack. So we have the OSI model, which is the most commonly accepted. You also have the TCP/IP model, which kind of lumps together applications, the session presentation and application layer becomes the most important part of that. And then you have what I call the software developer model. And any software developers in the room? Software people, software writers? There's a few of you. This is not meant to be an insult in any way, shape, or form. But what I've kind of seen is, like, the pervasive piece of this is that you interact with APIs. And APIs allow you a simple mechanism to not have to write quite as much code. And that allows you more reliable services, much better functioning applications, and so forth. But what they usually do is they provide you some level of these services that you can then write applications on top of. So you can select your presentation layer formats, whether it be Java and other things, and Java provides you with JBoss to drop your Java applets into, and that gives you web services and all those types of things. And so, but as we start to think about this, and as we think about the apps that you have on your phone, you're not thinking about devices and other things that are below them anymore. Software developers are not thinking about those things. They're trying to write code that's going to work pervasively across all of those things. They want to write one application that works on your iPhone, that works on your laptop, that works on your Linux box, that works on everything else. And so we have this ubiquity aspect that's coming into play, and how we're beginning to have this shift from how we, like I said, this connectivity to connectedness, where we had to write applications in this format where they understood that there were services and layers below them to provide interaction with other hosts. And now where applications are now interacting directly with each other because it's ubiquitous to the device. And so this kind of enters into the viewpoint of where we're going to take the rest of the discussion, which is that as devices become less and less important, and that's to say that they are important, but as they become less and less of the focus, where I can take my data across anything that I'm on, and as I no longer care about how I'm accessing this data, but the fact that I have access to it. Anybody following me here still? Like, who's asleep? Awesome, cool. Nobody's thrown anything yet. I'm really surprised. Should move on. Yeah. Yeah. I'm used to a little bit like feistier crowd. Like, you suck. Yeah. Where are those rockets thing? That provide a quick moving target. Yeah. I gotta watch out for that one. So it looks like my slide is all jacked up on this one, but nice, awesome. All right, I'm just gonna flip through this because my transitions are totally jacked up. So if we look at like encryption and how it's applied, back up a little bit there. Sweet. Fail. Okay. So let's talk about encryption for a minute. Anybody know where encryption lies in the OSI model? Anybody? Okay, and I'm kind of giving away some different stuff here, but where does encryption really lie? So you're seeing some protocols and stuff there. I kind of started asking this question last year of some security practitioners, and because I honestly didn't know the answer to the question. But it's like, where does encryption really lie? Because you hear about all these different encryption protocols and stuff like that. But anybody want to take a guess what layer? Yeah, a little bit all of them. But there is a right answer because it only exists at one layer. Even in all of these protocols, encryption, the encryption application, or like encryption itself, only lies at one layer. Sure. Wrong. It is the presentation layer. Okay. And why? That makes perfect sense, right? When we start to think about it, why does it exist at the presentation layer? You're taking data, clear text, putting it into ciphertext, and you have to render it, right? That's what the presentation layer is about, is taking data that's in one format and putting it into another one that's readable by another application and so forth. So when we look at this, when we talk about standards, the only place that encryption is really supposed to lie is in the presentation layer. And that's because whatever encryption algorithm that we're using to encrypt, it is a presentation layer format. So you have AES, and I put FIPS in here, but these are about standards. These are about algorithms and mechanisms to render clear text into ciphertext and back again. But when we look at this, we're looking at all this stuff, and we're like, well, wait a minute. Well, what does that, like, why is at layer 2 I've got PPTP and L2TP, and at layer 3 I've got IPsec and all this other type of stuff. Well, what does that mean? Well, it means that when you interact with encryption at that layer, you're really interacting, it's really going up the stack and coming back down. What's happening is that, whatever vendor or device or whatever thing you have has an application that's running in the background that's taking that data, running it up the stack, and bringing it back down again. So when we start to look at this stuff, we start to, obviously this is working, right? Obviously, these mechanisms, these implementations have never been messed with, and nobody has ever pwned them. Okay. And fail. So, they've never been man in the middle. They never been, So why are these getting, what makes these applications vulnerable? Like, what makes these different protocols and different things vulnerable to different things? Well, they provide, each of them provides their own layer of protection, and each of them is used and has some different means where it's the right thing to do. So I probably should have put this slide before the last one. But so in the OSI model, encryption equals presentation. If we look at the TCP/IP model, encryption is in this application layer. So when we talk about how developers implement it, it's a little bit less clear, cut and clear. And so what I'm trying to show you guys is that the reason that we're getting that these overall encryption is either A, difficult to implement, or B, easy to get around or to attack in many instances is because there's this challenge of like, where does it really exist? So in reality, what we see is instead of it existing at either one of these layers, it's all over the place. It's different APIs will provide some mechanisms for an encryption library at a different layer, but what you'll ultimately find is when you get to the root of it, the encryption library itself is a library that that an application interacts with to render that text. So it always exists at layer 6. Questions? Yeah, you suck, Evan. Sure. I have absolutely no idea, man. The reality is, and as far as like comparing, encryption protocols, so let me turn that a little bit on this, all right? So when we talk about encryption algorithms themselves, so you look at something like, you'll read these headlines that say, AES 256 compromised, or something like that. Is it AES, so I'm going to debunk something here, because in all the research that I've done over the past year, I have not read anything that legitimately said that a particular encryption algorithm was compromised in a means other than what it was expected to be compromised in. So if you think about like AES 256, it is an encryption algorithm that's rated just like a safe is. Like how many hours a safe or something like that is rated in, like how many hours does it take to burn through it, or how many man hours does it take to break in. That's how they rate the protection mechanisms of like security gates and other things. Encryption is the exact same way. So to say that it's unbreakable is not how it was ever intended to be stated in the first place. It was about, like, if you have this big of a computer and you have this much time, you're going to be able to brute force or get your way into this. So the idea behind encryption technologies and encryption algorithms themselves is to make it so that the data is no longer valuable in the amount of time that it would take you to do it. And so you implement encryption algorithms based on the time to value of that particular piece of data or that particular piece of information. And so when we look back at those previous things, we can start to see why, like, AES 256 gets broken. No, like a particular implementation of it does, because it fails to adequately address the security concerns, or it allows some mechanism to be bypassed where AES 256 is not even entered into. Because if the data is in ciphertext, it should theoretically take however long it takes, whatever that algorithm is rated in, to break it. Most of the time, it's poor implementation or a misimplementation of a particular algorithm. Now, can't get into that. That stuff is going to happen. That's not really the intent. What we're going to do is we're going to make some assumptions here, and we're going to trust that these algorithms are written and protect data in a manner as described, and that we're going to trust that we can use them. So let's kind of talk about this layer. So like I said, we're going to look at this non-ubiquitous layer where developers and applications and where the data that we're interested in interacting with resides. And we're going to look at some of the things that are in place right now to protect applications. So we're kind of getting into this thing that we were talking about. So we have all this different stuff. So if the presentation layer is where encryption exists, what's getting compromised? And the reality is that we either compromise sessions where we're reading data before it's encrypted, or we're interacting and able to forge who we are for purposes of retrieving that information, or we're going to look at data that we're able to extract it out of application space, memory space, and things like that. So if we started doing some research into the different protection mechanisms that are in place for modern operating systems and things like that. So you've got things like ASLR, address space layer randomization, I think that's what it's called, SE hop, certificate pinning, all these different types of things that are in place for protection of applications. So things like sandboxing are pretty typical and common things. But all of this, when they're in that layer, when they're in the application layer, they're almost always rendered in clear text, right? That's why I can use things like memory scrapers and the POS malware and all that type of stuff to get credit card numbers and all that type of stuff out of memory. And when it comes down through this next layer, it may or may not be encrypted. So when you look at like we trust SSL, right? SSL is a session layer encryption mechanism, so it doesn't get encrypted technically until it goes in transit. So now I'm lowering that level, like I'm allowing unencrypted data down into a lower level of memory space and session space that theoretically it shouldn't go to, right? Anybody following me here? Does that make sense? So then we talk about things that are at a lower level. So things like user authentication, user access control, AAA services, like where do those things terminate? Well, they terminate at the session layer. So you can make some assumptions or you can make some comments about it. It's not really the point of this presentation. There's an element of, like, do you trust that these things to work if they're implemented and that type of thing? If you properly choose these, they provide some level of protection. But ultimately, the myth of encrypted data is that, yeah, those things, if you were encrypting data in the right way and that when it went up to the next layer, it was either rendered as ciphertext, if it was done right, if this process was followed correctly, then theoretically those things, if it was to get compromised at the session layer, it would have been encrypted already, right? So a little theoretical here, but we go back to what we just talked about a second ago, which was that the attacks themselves on encryption are not coming at encryption themselves. They're coming at the various mechanisms above and below the presentation layer. And so ultimately, the failure of this is not encryption. Ultimately, the failure of it's not the application. The failure is that everything implements it differently. There is no standard for how encryption is implemented within applications or within operating systems themselves. And so we have this aspect of interpretation that can be taken. So the kind of the piece of this that we kind of got into was like, how can we create something that would be, or how can you interact with this data in some format that would be, you know, a little bit more straightforward. So you've got this aspect of the session. You know, you've got your interfaces and services, web services, you know, Apache or whatever you're running, and you have encryption libraries. Like I said, AES-256 may be a library. You have your application libraries, you know, your Java portlets and other things like that, or whatever they are. I'm not a developer, so you know, but you got all your API level stuff that's there that makes development to provide your application or provide your service a little bit easier. And then you've got things like up at the higher level layers that are, you know, application sandboxing, for instance, here is kind of a standard deal. Follow me still? Evan, you suck. So what if we kind of, you know, took this and provided something, instead of having it there, what if we provided something a little bit more standard that said, you know, we can't block access to encryption libraries, we can't block access to these different things, and we wouldn't necessarily want to, but what if we provided a library that was standard for a particular operating system that was open source, just like a lot of libraries are, that allowed a means to interact in a consistent way that would mean that data coming and going from it would be encrypted the right way? Theoretical, right? What would this solve, or would this solve anything? And the reality is it solves some of it, most of it maybe, but about half of it. You know, we have to provide a means for these applications, you know, for can we separate, you know, what's viewed by the application or what's viewed by the user and then what's used by the application? Because in most instances, those are pretty different things, right? You know, like in a Word document, the clear text that you're talking, that, you know, when you type your text into the Word document, only a very little bit of that is really important. All the rest of it's the, you know, the crap, the formatting, you know, stuff that's in it, and all this other type of stuff. What if I could just encrypt that part, the part that the application doesn't necessarily need to see, you know, for purposes of interacting with it? It can still do the rest of its stuff with all these other libraries and other stuff, but like anytime that we interact with human-generated data or things like that, can we provide a means to you know, for applications to interact with it in a standard way so that I can protect my information, but the application can still do its job, and you know, and I can protect that stuff going up and down? Any takers? Nobody? All right. So we still have to provide a means for some of this stuff to happen. So like the library itself can still interact with standard encryption libraries, so we're not locking ourselves into a particular encryption mechanism. Those libraries and other things can continue to interact at layer 6 to do what they need to do, and layer 5 can interact with, you know, the sessions and services and other things to create things. Theoretical, right? What if type of scenarios? But the reality is, like, something like this could theoretically work, and it could provide some level of protection. And then the application, you know, the 6.5 application or the library itself provides data back in a standard format for, you know, human interacted data or non-application interactive data that would go back to the app library and it would continue to get processed. So, preparation H. A through G were total failures. So we started looking around at, like, what's out there already, what kind of provides some of this stuff, and we're going to get into a handful of things, and this is where if you haven't taken your no-dos, this may be a good time. It's going to get a little bit more complicated from here on out. So we have some of these different kind of like what's out there already and how do things interact. So let's talk first about session layer stuff and how we identify users, and how do we provide mechanisms for secure user authentication, interaction, and stuff like that. And so we talked about the framework. Now we're going to kind of talk about a process framework at this point, and we're kind of jumping around here. I hope it starts to make sense towards the end. Otherwise, where are those little darts? Looking for you. So metadata, or when we talk about this, we've got some different standard stuff that we deal with every day, is like role-based authentication, kind of a standard mechanism for how users are paired with data. But we see that terminates at like a session layer. So the idea in like Active Directory, for example, is that if I'm a member of a particular group, then I have access to anything that group has access to. And it kind of doesn't take into account much of anything else. So then we talk about like how do we, some of these other aspects of things like mandatory access control, like, I can have access, I can be a member of a group, but if I don't have this other mandatory piece like, secret, top secret, whatever, then I can't access data up and down. And so I'm not going to get into like how all of this works, but hopefully you kind of understand the concept. Some of the newer stuff that's coming out that is out there already is like attribute-based. And so when we talk about attribute-based, some of these different types of information, and kind of what I kind of drew some lines out here, like metadata, like where does the information for this stuff come from? What are some current implementations, or what are some current things that you can think about, like how do I get the context, or how do I get information to do this type of authentication? And so some of the things like attribute-based, where we talk about like geo-specific stuff, that if you're in a particular location, you're allowed access to this data or whatever. Those types of things come into play, and so these are some technologies that aren't necessarily implemented in wide scale, or maybe have some very specific uses. Geofencing or something like that may be an example. So kind of think about it in that aspect, this attribute-based stuff. You've got metadata, PKI stuff, that trust-based risk reputation type of stuff, where like if I want to allow data, or I want to allow authorization to access particular resources based on some type of interaction that I provide based on trust or repute. This is very new stuff that's coming out, and people are trying to work with a lot. But like, what's in the middle of all of that? We've got this crazy Venn diagram up there that doesn't make a whole lot of sense. And so, what if we kind of took some of the pieces of this and said, like, what if we had like attribute-based access control and kind of combined trust and trust-based and reputation-based access control? It creates this concept, and something that I talked about very briefly in the presentation last year, is this concept of a policy decision point. So let's think about the policy decision point from an aspect of it's not just managing, we're no longer just managing users, but we have to manage access to attributes and other things, and data and so forth. And so a policy decision point creates, it's kind of like Active Directory or like any type of directory services utility that applies policy, but it's based on a larger subset of data instead of just users and groups and things like that. Follow me? No. So this is a slide from last year that I wanted to kind of skim over very quickly, because I'm going to run out of time. Some of the concept of this ubiquitous cloud, the idea to store anywhere, available everywhere. What if we could, have some of these things like trust-based repute and other types of things, multiple algorithms, that the framework that's not dependent on a particular algorithm to be successful, because there are different benefits of using different levels of algorithms based on speed or performance or whatever it may be. So we can't lock that in. We don't want to create anything. We need to use and leverage things that are already existing out there. We're not trying to create the next layer of something. But we can also, something that could take advantage of things like data tagging and journaling and all this other type of stuff, and support for all those different multiple access control methodologies that we talked about before. So we can't lock anybody out, but we want to provide a mechanism or a benefit to bringing those newer protocols and technologies in. Sounds pretty difficult. So we kind of started looking around and said, what's out there already? So there's a buttload of IETF, RFCs, and other things. All these standards, and if you think this talk is boring, oh my God, go read some of that stuff. But each of these kind of provides something that's a little bit different. So we've got some things like these, media type for reputation, interchange, geographic location data. What they're talking about is providing standards for identifying how applications can standardize the presentation, or standardize the, we'll just call it presentation. It's not necessarily a presentation layer library or anything like that, but like a format of what does like a standard geo information header look like, and stuff like that. And so these are things that kind of come into play if we want to try to make data, to integrate some of this data into our authentication decisions and our access decisions and our encryption decisions and all these other types of things. All right, and then I kind of wanted to stop here for a minute, because I know that this doesn't make a whole lot of sense. As my buddy Tom sitting in the seat here can tell you, it was kind of a beautiful mind moment that I had in a hotel room, and I started like writing all over the mirror with a freaking expo marker, and they start calling the people with the the white jackets and stuff, and they think I'm going crazy. But the concept that we kind of got to last year was this: what if I could create scalable per file PKI designed for this concept of ubiquitous computing, right? We're talking about going to the cloud and how everything will just be application to application. I don't care about devices, Google Chrome, for example, right? Your saved tabs. I can literally go on my iPhone and then go to my computer, and the tabs are all the same and all these things. How do you think that's happening? It's, the applications are talking to each other. It's PFM. But provides us with a means for active access control. And the reason this becomes important is because right now, everything that we have as far as most access control mechanisms are completely retroactive. They do not protect you into the future. They do not make smart decisions necessarily based on the latest bit of information that's coming into them, whether it be GeoIP or repute information or anything else. It's not to say that they can't. There are some people that are trying to do it, and they fail massively. That's why we have data loss prevention technologies, and those work so well. Anybody implement those, DLP? Yeah. Have fun with that. So what if we could provide something that's a little bit smarter than DLP that actually allows us to block something before it happens? So we have some things like active access control, blah, blah, blah. I'm going to keep going. Don't have too much time to go into this, but I showed this slide last year, and I just wanted to kind of go through it for purposes of kind of showing, we have applications that are protected. Oh, good Lord, go. How users interact with applications. They generate data. They have identities that they're interacting with multiple devices in. They create data. We start to encrypt this data in context of domain and user identity instead of encrypting it for purposes of like dropping it to a file system. That data ownership and other things can be managed by a policy decision point that could be specific to an individual user, where the user can make decisions on their own about how that data is accessed and shared, and where you can control. That's the concept of this talk, which is allow myself to encrypt myself. How can I maintain ownership of my data? How can I prevent, still interact with the Facebooks and the other applications that I want to interact with, but not necessarily provide them any information. I can use their application, I can generate data in context of that application, but still ultimately control what they can and can't see. And that sounds pretty crazy, like how do you do that? But there are some interesting, like I said, we've kind of outlined some of the ways that could work. The next piece of this is that we kind of debunked or kind of threw out this concept that I have to keep, that encryption keys, public-private keys, are specific to users or applications or devices even. What if I were to give public-private keys to contexts, to attributes in my architecture? What if I were to encrypt things in the context of a role or a user role? And so a domain can own a domain role can own the public-private keys and encrypt things specific or in context to it. And because it owns those keys, it can prevent data loss, right? If you come and request that data, you have to request an unencrypted copy or a re-encrypted copy of the data. So let's look at this. So what if public-private keys were more than just systems and users? What if, and I get this argument, some people are going to talk about, what about the overhead of this stuff? The reality is all this stuff is really happening in the background where people are appending data and encrypting between services. So if you have time, I can tell you why that's complete bull crap. What if keys were disposable just like sessions, that if a key gets compromised, I don't care because I'm just going to, the data ownership of it is still in context of a user, of a domain, just like you have with, any other authentication mechanism that you have. And what if we provided a simple mechanism to regenerate encryption keys so that we can take into this concept that things are automatically, that they're going to get compromised, right? So this is the patent. Last year we went through and I know this looks like insanity. I'm going to try to go through it in about like 5 minutes worth of time, which they're telling me I have. So last year out of the talk, we had some guys come up to us and they were like, you can't talk about this, you need to protect this stuff. And I did not necessarily see that at all. I had no idea why anybody would, we were throwing out crap and seeing what stuck. But so one of the things that this kind of takes into account, we've kind of hit on each of these, and I'm going to try and draw it together here in the last 5 minutes. And you have this concept of a trust domain, which is what most of us interact with, and this is the most common type of domain, right, where you have users and devices, you have roles and identities and things like that you interact with and you generate data in the context of. And so I know that that's kind of small and stuff, but really what we're showing is that a user interacts, what creates an identity ultimately for a user is the interaction of multiple devices, a device and application, and a user login and things like that. And then I can, in the context, I log into a domain, some type of AAA or something like that, and I, have a user identity interaction and all these different types of things as you kind of go down through this process. And so ultimately these are, this is kind of the shift where, and the reason that devices and applications are outside of this trust domain is the concept that, BYOD, for example, I'm no longer just, these devices don't necessarily belong to an organization. They're ubiquitous, right? I'm coming and going from them, and organizations are allowing you to bring your, own assets and things like that into the workplace. So that aspect of those devices is becoming less and less relevant. So what if we don't care about the devices? What if we don't trust them? So we talk about, then we have data domains. And so we understand data domains. There are existing things out there. So we have got abstracted data fields. So you have data fields and types that tie together to create objects and models. And then you can create policy based off of, if this IP plus this, social security number plus this, whatever, you can start to create data models and relate objects to each other, and they create context. Like I said, not going to get into that too much because there's stuff there, but we're seeing this shift to kind of, some of this user-defined stuff, so like data tagging within operating systems where you can create, regardless of where that data sits in the operating system, you can have a tag or a context that brings it all together and makes it relate to you. So that's there. It can get really granular, it cannot be. So if you think about Gmail labels, like how do they create those labels for you automatically? It literally can be that simple, how you create policy on these things. So what if we extended this schema? We took that idea of providing keys to more than just individual things. We provide it to policies and users and devices and all this other type of stuff. And we've got things like key management and stuff like that. It makes things much more flexible. What if we, and it also starts to provide this aspect of where we can do like real trust-based modeling. So we can extend the amount of data that we can control access based on and that type of stuff. I'm going to talk about this, how the data protection domain kind of works. I'm going to publish some of this stuff up, and like I said, I'm going through this very, very fast. I probably should have gone through the beginning stuff a lot faster. But in a data protection domain, so it's kind of the bridge between trust and data domains. And so you create a context for how data is interacted with and how data gets encrypted and unencrypted. And so you aggregate this policy. You can provide extended schema protection. So like if you want to, one of the basic things that we talk about is inference-based attacks and stuff like that. If I'm providing, how do I search for metadata, or how do I search for data inside of encrypted data and some of those things. If you've got questions, I'll bore you to death on that stuff. But continuing to talk about data protection domains, you have, data is published in the context of each individual application or each individual piece that's requesting that data. So we talk about those verticals of devices and applications and other things. Each of those have encrypted data based on the public-private keys for that particular instance of that piece of data. So it provides a much more robust and less revealing piece of data encryption, so that the device only ever sees things that it absolutely needs to see to perform its function. So the last piece of this that I'll really get into is process pipes. And the aspect of process pipes in the framework are to allow existing technologies and future technologies to interact with the framework. And the reality is that we have no idea how we're going to use this in the future. We have no idea what applications are going to exist and what context we're going to want to interact with data, how data is going to get generated and so forth. Existing AAA services that are here now aren't going to be here in the future and so forth. So what the framework gets away from it. So we provide in multiple places aspects for process pipes to interact with data, to provide like context for data loss prevention technologies or things like that, to tag data and so forth. So we're staying away from identity and access management. That's a process pipe. We're staying away from end user and certificate management. Those tools and technologies exist. That's a process pipe. Data and storage and transport. Those processes exist. We're not talking about those things. We're talking about how to put them all together in a framework that allows you to protect your data and allows you to control your data in the aspect of how it's used in the future. So one of the things that I had talked about last year was like data destruction through certificate revocation. And the idea is that all this data is created with certificates that are managed by the policy decision point. And so if I realize that data has been compromised, or maybe I see like a virus or piece of malware is running around my network, I can instantly kill access to that piece of malware by revoking the certificate, because it has to have a certificate to be reversed and opened up into clear text to operate, right? Everybody follow me? I'm going really fast here. So what does it do? It provides some practical protection mechanisms. The framework assumes compromise, right? Like, so all I've got to do is just revoke these certificates and the data goes away, right? But that could have negative impacts as well. But we can re-encrypt data. So, but what the biggest thing is that it talks about is that it requires more than just compromising a user's identity. it's very easy to, you would have to compromise multiple aspects of the technology in multiple places to really get access to all the data to put it in complete context. And so it's kind of a small slide there, but some of the things that asymmetric encryption, I'm going to breeze through this, provides confidentiality, man-in-the-middle protection. So some of the things like SSL and other symmetric ciphers are vulnerable to. It provides a level of protection above that. It gives you integrity and non-repudiation, which you do not have in current encryption implementations. So it actually allows you to know what device, what user, what application, all those different things that are important to you to develop true context and IP and reputation policy. And it also could require online access so that if somebody steals your data now and they take it off site and they want to crunch it, they can't open it because they have to come back to you to get that data or to get the approved unencrypted version of that data, re-encrypted version of that data. Metadata tagging, custom policy and context, journaling, machine-based ontology limits data exposure and inference attacks. And this is I put this in here on purpose. I've gone cross-eyed. If you're not ready to kill yourself now. So obviously some of the things that are still there, you have to protect the keys, but what we're providing is a mechanism where keys and key exposure is a little bit less important. So some of the things that we ran into pretty early when we started trying to test this was like impractical data types. So like, how do I encrypt streaming video or audio or something like that? Maybe I do or don't care. But the reality is that we've kind of come up with some ways. So what makes like symmetric key ciphers vulnerable to attack is intercepting the symmetric cipher on one end or the other. But what if I used, so those ciphers are much more efficient. I'm not going to send every single video packet, PKI encrypted. That would be very inefficient. But what if I exchanged that symmetric key with those private keys? That instantly allows me a little bit higher level of protection. I know I have that non-repudiation and stuff like that on the endpoints. Yeah, it's still vulnerable to replay attacks, but maybe that's worth it. Processing network overhead. We're talking about the future here, right? We're not going to have memory and disk space and other problems in the future. I know. Yes, there are tons of problems and tons of cool things to solve with this. One thing that I didn't get to talk about last year was how do you attack the framework. And this was the biggest thing that people came up to us afterwards was this second piece was patent trolls. And until we started looking, we had no idea. We didn't really consider this concept as patentable, but apparently it is. And so that's the biggest vulnerability that I have right now is exposing a concept framework to you guys that somebody could then take and potentially patent and lock it down and prevent all of us from doing things with it. But more likely, things that are going to be attacked is people are going to try to attack the rules, attack the libraries. DOS is always a big deal. Race condition attacks. I don't have time to talk about them, but it's the concept that I can, if I can steal the data and compromise the keys before you can revoke them, whatever that finite time period is, that I can then get access to all your data. So I'm going to blow through this. Some of the things that we're using to test this, web ontology languages, attribute-based access control. Anybody that knows me will tell you I drink a lot of Red Bull, and dang it, and I have yet to grow any wings. You got to love that like auto-advancing slide type of deal. So to keep you guys up to date, come on. Provisional patent protection is there and in place since last year. The reason I mention this is that I'm not an expert in this stuff, so I need some help. Currently we're researching some of the most appropriate mechanisms to release this as a open source framework that people could leverage. So on that note, I ran out of time, as I always do, because I like to talk too much. But I know it was good for Adrian. He left. If you guys have any questions, I appreciate you guys listening and listening to me ramble. Some of the guys that contributed last year that were really influential in kind of advancing us to go to take this and get a patent and things like that, so that the community could continue to use it and to advance this concept. But anyways, thanks guys. Go.
You said that encryption lies on the presentation layer. Doesn't also lie on the session layer? Doesn't also lie on the session layer. Can you tell me why not?
Okay, the reason it doesn't rely on the session layer is because the session layer has to it has to take the data that it's receiving, run it through an encryption library, and bring it back. So like you're rendering clear text into ciphertext and sending ciphertext out. So like even your session layer application is taking it and putting it through some type of presentation layer library to render it into a format that it can then can send and interact with the session layer protocols in.
Oh, I see. But isn't the session layer also important in encrypting ourselves? Now, not in the framework we presented. I mean now.
Mm-hmm. Well, I mean, it's always there. Like the reality is that
like SSH and all this stuff.
Yep. The reason though ultimately those are compromised is because data is unencrypted at SSH. Like it doesn't get encrypted until the session layer receives the clear text data, sends it back through an application library, and receives it again. So instead of it always being like never going below the presentation layer encrypted, like that's where the man-in-the-middle attacks kind of come into place, is because if I can intercept it either above the presentation layer or below it, those are the vulnerabilities. So how can I keep data in the application stack encrypted for as long as absolutely possible? That's what the concept of the application framework is about.
Okay, thank you.
Sure.
Okay, we've got time for one more question.
Are you concerned at all about something like governmental regulations saying that they have to backdoor it so that the NSA or the CIA or the FBI can read and subpoena the data?
Absolutely, and the reality is that there is absolutely no way that I could do that because the idea is that this is just a framework. We're not providing an encryption algorithm. We're not providing any mechanisms for people to encrypt themselves. We're not exporting anything that would be controlled, all that type of stuff.
Right. But it could be a practical limitation in terms of how the government regulates this sort of implementation, saying that Google has to always backdoor it or something like that, right?
Theoretically, they could, but ultimately, just like PGP and just like a lot of these other ones, like if we as a user community provide our own mechanism to do this, so like, yeah, if you want to trust Google to provide you with this, service or whatever, absolutely. I mean, you're trusting them that they're doing the right thing with your data. But the idea of the framework is that it's open and anybody can use it to create their own, key server and key management and policy decision point and that type of stuff. The process pipes are designed into the framework on purpose so that you can interact with the data, or that you can provide data in a format that is practical to your implementation but doesn't lock you out of using other applications and services.
Great. Well, we'll have to leave it there with our tinfoil hats firmly in place. If anyone has any other questions, then feel free to hit Evan up.